The fact that Earth has only one moon makes it different from other planets in the solar system. Jupiter, which has 79 known moons in orbit, is unique and important to exploring our solar system. Unlike the Earth's satellite, the activities are not always visible, many things happen in other moons. Io, one of Jupiter's moons, is a good example of this. Unlike our quiescent moon, Io is a constantly changing world, where volcanic activity and surface changes are occurring on a scale unlike anywhere else in the solar system. The first observation of Io was made in 1610 when Galileo Galilei observed Jupiter with a single telescope. During these observations, he also discovered 3 other moons of Jupiter, Callisto, Ganymede and Europa, known as the Galilean moons. Interestingly, just one day later, Simon Marius, a numerologist and astronomer, recorded his observations of Jupiter and noted yes in those months. Marius was the first to claim the name Io for this moon, which comes from Roman and Greek mythology, where Io was a priest and lover of Zeus, the Roman Jupiter. Despite Marius' suggestion, the moon was simply called Jupiter I for years before the name Io was widely adopted. Io is the innermost moon of the Galileans and the third largest among them, with a diameter of over 3,600 kilometers, slightly larger than the Earth's moon. Our moon has the same force as our moon, and Io's pull is 1/6. However, Io is much less massive, weighing 89 trillion tons compared to Earth's moon of 70 trillion tons. Io orbits Jupiter in about 42 hours, and because its rotation period is the same as its orbit, Io looks like Jupiter, just like our moon does on Earth, a phenomenon known as tidal lock. Despite its smaller size, Io's surface area is only slightly larger than Switzerland, about 42,000 square kilometers. This moon is about 421,000 kilometers from Jupiter's surface. The journey from Earth to Io is a long journey of more than 628 million kilometers. Even before we got close to Io, the moon was famous for making the first measurement of the moon's speed. In the 17th century, when there was still debate about whether the moon was accelerating or not, the Danish astronomer Ole Romer used an eclipse of Io to make a bold prediction. He calculated that Io would rumble 10 minutes later than expected, and when this prediction came true, he showed that the moon was moving slowly. Exploration of Io began in the 1970s with the Pioneer 10 and 11 spacecraft, which visited Jupiter and its moons and took the first close-up images in 1979. They followed from the Voyager 1 and 2 missions, in great detail. Images were taken, and the New Horizons probe took a long time to image Io on its way to Pluto in 2007. Juno reached Jupiter in 2016, taking several images during its flyby. Although his first goal was to study Jupiter itself. However, Galileo's mission made a significant contribution to our understanding of Io. Galileo's mission was important in the discovery of Io. Galileo's Moon Explorer was launched to Jupiter in 1989 and arrived 6 years later. Unlike previous missions, which largely bypassed Jupiter's moons, Galileo orbited the gas giant and focused on its 4 major moons. Galileo was originally supposed to end its mission in 1997, but it continued to operate for several more years, during which it conducted close flybys of Io. This mission brought to light some of the most remarkable features of Io, but it eventually ended in 2003 when the probe was deliberately sent into Jupiter's atmosphere, where it burned up due to technical failures and lack of fuel. On July 3, 1999, Galileo captured a remarkable snapshot showing Io in all its vibrant colors and revealing the moon's dynamic surface structure. Io is full of volcanoes and high mountains, although much of its surface is relatively flat. Some mountains rise as high as 9 kilometers, while the surface itself is geologically young, estimated to be only several million years old. This youth is due to the intense geological activity that is constantly changing the Earth of the Moon. The tidal forces of Jupiter and its surrounding moons create strong tides on Io, kneading the moon's interior and fueling its volcanic activity. Io is the most active volcano in the solar system with over 300 active volcanoes. This volcanism is what sets Io apart from other moons and planets. Unlike many moons covered in asteroid belts, Io's surface is constantly being renewed by volcanic eruptions, and there are no volcanoes. The number of volcanoes on Io is amazing, some are hundreds of kilometers across. The first images of volcanic eruptions on Io were taken by Voyager 2 and are the first time such activity has been seen on a non-terrestrial body. One of the most famous volcanoes in Au is Lokipatra, named after the Norse god of fire. This 226 kilometers wide volcano has frequent eruptions, with cycles varying from 475 to 540 days. The intensity of these explosions is so high that they can be seen from Earth with a telescope. Volcanic activity on Io affects the Moon's atmosphere, which is mostly sulfur and other gases. The atmosphere is only 120 kilometers high, but it can be severely affected by volcanic eruptions on the Moon. The incredible volcanism on Io is responsible for the Moon's lack of water. While Jupiter's moon, Europa, is believed to have a watery subsurface ocean, Io has no water. If there was water on Io, it would have evaporated long ago, due to volcanic activity in Jupiter's gravitational pull, removing the water vapor. Beneath Io's surface, scientists suspect an endless ocean of magma that feeds the Moon's volcanic eruptions. Lokipatra, the largest volcano on Io, is a beautiful sight. With a diameter of 226 kilometers, it erupts periodically and produces enough heat to be visible from Earth. The explosions of Lokipatra contribute to the total heat produced on Io and become the main driver of the Moon's activity. These explosions are powerful enough to be visible from Earth, adding to Io's status as one of the most spectacular moons in the solar system. Io's atmosphere, like everything else on the Moon, is affected by its volcanic activity. The atmosphere is thin but dynamic, mostly sulfur dioxide, and constantly replenished by volcanic eruptions. Despite its thinness, Io's atmosphere is an important part of its entire environment, contributing to the Moon's unique position in the solar system. Io is not just a moon. It is a world that is constantly changing, and the landscape is changing almost every day, where the forces of nature are very powerful. Astronomers and scientists around the world are fascinated by Io's uniqueness, and images taken by spacecraft over the years have provided valuable insights into this vibrant moon. Io looks like a tiny dot from Earth, but up close it's a very impressive and fascinating world. The geological activity on Io is unlike anything else in our solar system, making it one of the most interesting things to study. Looking to the future, ESA and NASA have planned a new mission to explore Jupiter and its moons. However, NASA has withdrawn from the mission, and ESA has switched to the 3 moons of Galilee. It is uncertain whether Io will be visited again in the near future, but the moon's unique properties will continue to be a subject of fascination for years to come. Io's story is one of endless change and dynamic. From its discovery in the early 1700s to detailed observations by modern spacecraft, Io has captured the imagination of scientists and the public. Its explosive nature, the mystery surrounding its internal structure and its frequent volcanic activity make Io a world unlike any other in our solar system. As we continue to explore the solar system, Io will undoubtedly continue to be a key target for future missions, offering the possibility of further discovery of space-based forces. Then our celestial neighbors.